So today we're going to work on square roots, which is a new concept, and it's an important one that we're going to be working on for the next couple of years throughout math. So square roots are kind of the opposites of exponents when you square something. So if you look at this problem here, 3 squared is going to be equal to 9. 5 squared is going to be equal to 25. Now, if we use this symbol here means take the square root of something. And if we go ahead and we put this here, square root of 25, we're looking for what number times itself is equal to 25. And that's just going to be equal to 5, because 5 times 5 equals 25. And up here, if I say square root of 9, that's going to be equal to 3, because I'm looking for what number times itself equals 9. So in these problems here, think for a second, what is the square root of 100 going to be? Okay, so you should have come up with the square root of 100. What number times itself equals 100? That's going to be 10. And now the next one, the square root of 64. What number times itself is equal to 64? That's just going to be 8. So now we're going to get into a couple of things that are just about the notation of the squares and the use of the square root symbol. Sometimes you will see a problem where it says the following. Square root of, let's see here, 121. And it will have out in front of it that symbol there, the plus and minus. That means the solutions are either going to be negative 11, because negative 11 times negative 11 gets us 121, or positive 11, because 11 times 11 equals 121. And so if we see the two symbols here like this, that means that there are going to be two solutions. There's also another one where if you have something like this, the square root of 36, and it just has a negative in front of there, then it is just asking you for the negative square root. So what's the square root of 36? What number times itself equals 36? It's going to be 6, but it's just asking for the negative value. Now up here, these ones here, it's automatically assumed if you don't have a negative symbol or this plus minus symbol here, that you're just looking for the positive square root. That's why it's positive 10 for that one. So in this type of problem, it says find the square roots of 16, 144, and 1. In this case here, you're not being given that symbol, so you're being asked to figure out what number times itself equals 16. And for that answer, there's going to be two. There's going to be the negative value, which is going to be negative 4. And the positive value, which is just going to be 4. Frequently, the way we would write that is just plus or minus 4. So this would be the answer to that first one. And if you know your multiplication facts, then you know that this next one is going to be plus or minus 12. And what's the square root of 1? That's going to be plus or minus 1. So 1 times 1 equals 1. So the numbers we've been working on so far with square roots have all been the ones that have been on the right-hand side of this line. And those are called perfect squares because they're one number times itself equals that exact value. So for this one here, it's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. So those are called perfect squares because when you take the square root of 25, you're going to end up with positive or negative 5. Most of the time it's not going to happen that way because there's a lot more numbers that are not perfect squares than there are perfect squares. So if we look at this problem here, it says approximate the square root value of 59. The way I'm going to do that is I'm going to think what's the perfect square that's closest to 59, and that would actually be 64. So, and then what's the perfect square that's below it as well? 49. So that means since the square root of 49 is 7 and the square root of 64 is 8, the square root of 59 is going to be between 7 and 8. If you look at this next problem, approximate radical 37. So that means, again, I'm thinking what numbers are the perfect squares that are that have 37 between them. So I'm going to look here, 36 and 49. That means radical 37 is going to be actually less than 7, because the square root of 49 is 7, and greater than 6, because the square root of 36 is 6. So in these problems here, you're being asked to solve for x. And just like when you square something, the opposite is going to be to take the square root of it. So in this first problem here, to undo that x squared, because I'm just solving for x, I don't want x squared, I'm going to take the square root of x squared, and that's going to leave me x. It just is undoing that squaring part. So that means I've got to also take the square root of 49. That's going to be both the positive and the negative. Because again, if I'm taking the square root of x squared, that's just going to be x. And then the square root of 49 is going to be plus or minus 7. So in this problem here, it's x squared is equal to 100. I'm going to square root both sides. That just undoes that x squared thing and just leaves me with x. And then I have to take the square root of 100. The square root of 100 is going to be square root of 100, positive or the negative value of that, and that's going to be plus or minus 10. Now down at the bottom here, I have 5x squared is equal to 125. I've got to get rid of that 5 before I do anything with taking the square root. So I'm going to divide both sides by 5, just like if this was 5x is equal to 125. When I do that, I'm left with x squared is equal to 25. Now I take the square root of both sides. I'm left with x is equal to positive or negative 5.